Example number 1. Find the degree of each of the polynomials given below. 1 x to the power 5 minus x to the power 4 plus 3. Second, 2 minus y square uh, minus y3 y to the power 3 plus 2y to the power 8. And third, 2. Solution is, here three examples are here. This term x to the power 5 having the highest power index, here this term 2y to the power 8, and here it is a uh, uh, no variable, so you can say y to the power 0 or x to the power 0, like that. So degree of the polynomial will in all the three cases here 1, 2 and 3 will be uh, different, like 1, the highest power of the variable is 5, so the degree of the polynomial is 5. Second, the highest power of the variable is 8, so the degree of polynomial is 8. Third, the only term here is 2, which can be written as the 2 into x to the power 0, so the exponent of x is 0, and therefore the degree of the polynomial is 0. Now observe the polynomial px is equal to 4x plus 5, qy is equal to 2y, t is equal to t plus root 2, and su is equal to 3 minus u. Do you see anything common among all of them? The degree of each of these polynomial is 1. The polynomial of degree 1 is called a linear polynomial. Some more linear polynomials in one variable are 2x minus 1 root 2 y plus 1 2 minus u. Now try and find a linear polynomial in x with three terms. You would not be able to find it because a linear polynomial in x can have at most two terms. So any linear polynomial in x will be of the form ax plus b, where a and b are constant and a is equal to not 0. Similarly, ay plus b is a linear polynomial in y. Now consider the polynomials 2x square plus 5, 5x square plus 3x plus 5 x square, and x square plus 2 by 5x. Do you agree that they are all of the degree 2? The polynomial of degree 2 is called a quadratic polynomial. Some example of quadratic polynomials are 5 minus y square, 4y plus 5y square, and 6 minus y square. Can you write a quadratic polynomial in one variable with four different terms? You will find that a quadratic polynomial in one variable will have at most three terms. If you list a few more quadratic polynomials, you will find that any quadratic polynomial in x of the form ax square plus bx plus c, where a is equal to not 0 and a, b, c are the constants. Similarly, quadratic polynomials in y will be of the form ay square plus by plus c, provided a is equal to not 0 and a, b, c are constants. We call a polynomial of degree that a cubic polynomial. Some examples of a cubic polynomial in x are 4x to the power 3, 2x cube plus 1, 5x cube plus x square, 6x cube minus x, 6 minus x cube, 2x cube plus 4x square plus 6 plus 7. How many terms do you think a cubic polynomial in one variable can have? It can have at most 4 terms. These may be written in the form ax to the power q plus bx square plus cx plus d, where a is equal to not 0 and a, b, c and d are constants. Now that you have seen what a polynomial of degree 1, degree 2 or degree 3 looks like, can you write down a polynomial in one variable of degree n for any natural number n? A polynomial in one variable x, the degree n is an expression of the form a n action plus an action plus an minus 1 xn minus 1 plus n minus 2 xn minus 2 plus dot dot, here given already, plus a1x plus, ultimately it will be the a0, because x to the power will be here and here x to the power 0, that means 1. So where a1, a0, a1, a2, a3 dot 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 an are constant and an is equal to not 0. In particular, if a0 is equal to a1, g is equal to a2 is equal to a3 is equal to dot 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 n is equal to 0, all the constants are 0, we get the zero polynomial, which is denoted by 0. What is the degree of the zero polynomial? The degree of the zero polynomial is not defined. What is the degree of zero polynomial? The degree of the zero polynomial is not defined. So far, we have dealt with polynomials in one variable only. We can also have polynomials in more than one variable. For example, x square plus y square plus xyz, where variables are x, y and z in the polynomial in three variables. Similarly, q square plus p square plus q to the power 10 plus r, where the variables are p, q and r, u to the power 3 plus v square, where the variables are u and v, are polynomials in 3 or 2 variables respectively. We will be studying these polynomials in detail later. Now exercise 2.1 is given. Some questions are there, you have to solve all the questions. Next point will be the 2.3, that is the zeros of a polynomial. Consider the polynomial the px is equal to 5x to the power 3 minus 2x square plus 3x minus x minus 2. If we replace x by 1 every, where in px we get 4. So we say that the value of px at x is equal to 1 is 4. Similarly, p0 is equal to minus 2. You can find p minus 1.